Testing, testing.
Seem to be a natural pair. They're almost like soup and sandwich, or love and marriage, peanut butter jelly. It's really, they're just a natural pair. And here's where I'm going with that. You can't have a meteorologist that doesn't know something about astronomy, and you can't have an astronomer that doesn't know something about meteorologists. For instance, you can take the most inexperienced stargazer, or somebody as famous as the Carl Sagan, and both of them, if they were telling you about an upcoming celestial event, they would promote it with great fervor, as they always do. But in the end, I guarantee that the last two words that they would say, or should say, would be weather permitting. Now, think back to right before Christmas in 2020. Remember how the media was all pumped up and kept telling us for weeks in advance that there was going to be these two shiny objects in the night sky, and one would be like a star of wonder, and one would be a star of light, and they would merge together, and we'd get this star of royal beauty, right? And oh, it was going to be so exciting. Nobody'd seen it for 800 years, so we all went out and looked, and did we see it? No. Bummer. Too many clouds. In fact, my husband's weather records are right, and I know they are. It was 21 days before the skies cleared enough for us to see much of anything in the night sky. But that's okay. I don't want to sound too discouraging. There's going to be plenty of stuff for us to see in 2021, weather permitting. Now, let's talk a little bit about meteorologists on the other hand. I don't care if somebody has a doctorate in meteorology, or if they're a woody weather guesser, or maybe they're just a common cloud watcher. Regardless, they can't totally detach themselves from astronomy, because after all, when you think about it, it's one single star, one average size, not so hot star, the sun, that is the driving force behind all of Earth's weather. I was fortunate enough to connection between, can you mute the people, please? I was fortunate enough to make the connection firsthand between meteorology and astronomy. A few years back, when I was 18 years old, I was an aerographer's mate for the United States Navy. I was stationed far away from home, way out in Alameda, California.
Jann. Yeah, you're muted somehow. He muted everybody, including you.
Okay. All right. I'm not going to rewind that to day one. 10 seconds, okay? So I'm stationed at Alameda, California. I'm the lowest ranking sailor in the watch session, and I'm given the task of doing the weather observations. Now, this was kind of a ho-hum task until it got dark and I was exposed to the wonder of the night sky. And then, oh my gosh, up until that point, I don't think I'd ever spent more than a couple minutes looking at the night sky in the middle of the night. Maybe quick trips to the latrine during Girl Scout campouts, but that was it. But now I was required to go out for 10 minutes every hour and take a weather observation. And oh my gosh, what I didn't see. I saw shooting stars, dozens of shooting stars spanning the whole night sky. I saw planets perfectly posed above the Golden Gate Bridge. It was awesome. I saw lots and lots of halos and spectacular sunrises, but I had to get back in the building before the exact moment of sunrise because KFRC radio station, San Francisco, always played the #1 song at that time, which was Here Comes the Sun, right at sunrise. All right, so let start our actual presentation, share screen, go up here to the title of our program tonight, and it is called Whether or Not. And it's dedicated to three men, Dan Maley, Mr. Dance, and Mr. Gomez. Now, I wanted to do this. These are my three bosses at the weather office at Weather Forecast Incorporated down at Burke Lakefront Airport. And at least one of these gentlemen is listening in tonight. And they were such great mentors, and they continue to be lifelong friends. So, whether or not, we're going to start with the moon and stars and the weather. Let me get a drink. Okay, now it's not advancing to my next slide. So, and why might that be? There we go. The moon and the weather.
This Monday evening, New York Governor Andrew Cuomo under fire and under investigation tonight, facing accusations of sexual harassment. Tonight, his newest accuser saying Cuomo refuses to, quote, take responsibility for his predatory behavior. The governor, praised for his leadership when COVID hit, is also now facing growing questions about the data on Earth.
They muted you again with everybody else.
Jan, they muted you again. When they meant to mute, does everybody out there know how to mute themselves? Could be helpful down in the corner of wherever you are to mute yourself, so we don't have to mute you, Jan.
I got me unmuted.
There you are.
I'm unmuted, and now I'm back, and now I'm sharing, and it says the moon and the stars and the weather. All right, here we go. Thank you for being so patient. And it still won't go. It still won't advance. Nope.
Somebody's just punching out. Did you see that?
Okay. There are many old weather wisdoms that have to do with the moon. They can actually be divided into two parts. There's the ones that are very reliable, considering how accurate most weather forecasts are, and the ones that are just a bunch of hooey and should be trashed. The ones that are absolutely never reliable are the ones that are phase-based. For instance, these here, we're looking at the crescent moon. Now, depending on how the crescent moon appeared in the sky, old-timers used to think that this was a way you could figure out how much weather was coming your way. You take a look at this first one. This was called a wet moon. Now, if you saw this moon up in the sky, you're saying, okay, this is not good for my plants because the moon is hoarding all the rainwater. No chance of rain for you. On the other hand, if your crescent moon that you're looking at was the one over here on the right, that was called the dry moon. The dry moon had just dumped out its entire bunch of rain onto the ground. It's time to roll up your pant legs and gather up your skirts because it's going to be wet weather for a while. The middle one here was called the dripping moon. Now, I couldn't find any exact interpretation of the dripping moon, but the dripping moon probably would equate to something like today's 30% chance of widely scattered thunderstorms in an isolated area after midnight. That's what I'm guessing. Now, here's another one. Remember, though, this is what people used to think. And these were just totally not good. Now, these became sort of semi-scientific after a while. Herschel's weather table. Here we have a famous astronomer, Herschel. John Herschel was the one who charted the constellations in the southern hemisphere. And we got that link going on here between weather and astronomy. So he's an astronomer, and he makes this very interesting looking weather chart that it's only accidentally accurate. It's kind of like that mantle, or clock that's sitting on your mantle that you can't quite throw away because it's correct. The correct time is on there twice a day. This, again, is not accurate.
Jan, when was that brought about?
This Herschel's weather table came about in 1815. It was published, and by 1882, there's another gentleman that obviously had gotten tired of all this malarkey, and he made up a very interesting weather saying to go along with it. He said, the moon and the weather may change together, but the change of the moon does not change the weather. If we had no moon, and that would seem strange, we still would have weather that's subject to change. All right, so we're going to disregard all those phase-based ones, and let's talk about a few moon weather sayings that are pretty reliable. Whoops, got to remember to go over here. So, it doesn't matter if you're looking at the gibbous moon or half moon, quarter moon. Here we got the full moon. The saying is, clear moon, frost soon. This was very good for an immediate forecast, especially if you're into gardening or maybe you're into farming. It's the spring, it's the fall. I have got young seedlings coming up. I need to know if they need extra protection tonight. Looking up at the moon, it looks very clear. There's no clouds up there to hold in the heat. Clear moon, frost soon. On the other end of the season, my summer crops are all but in. There's a few left hanging on the vines. I don't know if I should bring them in or not, but looking up at the moon, there's no clouds obscuring the view of the moon. Clear moon, frost soon. I better pick those tomatoes and bring them in so they don't get frozen. Check out this one. What's going on here? There's this big circle around the moon. The saying is, ring around the moon, or so soon. I like old weather sayings because they're easy to remember and therefore they're easy to share. We get this ring around the moon because the high-level clouds that are allowing this ring to happen are called cirriform clouds, and they're made up of ice crystals. And when the moonlight's shining through those ice crystals, it's almost like the prism effect. Here's a more scientific explanation of what's going on here. The prismatic quality of cirriform clouds refract lunar luminescence in a circular bow about Earth's natural satellite in advance of an approaching moisture-laden system. Who's going to remember that? But you might remember ring around the moon, rain or snow soon. And oh man, I can't even say the word halo without thinking about the awesome halo that was above our cabin last September. I was on my way to babysitting and I looked up this big halo around the moon, and right up on the edge of that halo, perched on the very end, was the planet Mars. It was the most magnificent sight. Now here's another crescent moon. Now remember, we're not going to use it to forecast rain, whether it's dripping or wet or dry, but we are looking at it and it looks very, very clear. Look at those edges. Look at those horns of the crescent moon. The saying was, sharp horns do threaten high winds. If you're seeing the moon in this phase, and you can see, it doesn't have anything to do with the phase. If you're seeing the moon with this degree of clarity, that means the atmosphere has been flushed out of all particulates. There's probably high winds, and those high winds will eventually usher in some stronger storms. The Native Americans who shared their agricultural practices and tips with all the pioneers, they also shared a lot of their weather wisdoms with the pioneers. One of the things that recently seems to be trending is to hear TV weathercasters and different publications that you pick up will have begun to tell us the name of the full moon using the old names that the Indians had ascribed to them. Now, these weren't forecasts. These were climatological statements. Okay, the December moon was called the cold moon because the month of December was when the colder temperatures really set in. February, we just had the other night the snow moon. Maybe you saw the snow moon. The snow moon woke my husband and I up on Friday morning. There was just like this big spotlight coming in the window, like they used to shine in the back of cars to see if people were making out in the back seat. I don't know how I know that, but the snow moon just was fantastic. Lots and lots of moon shadows. February is the snowiest month typically of the year, according to the Native Americans. The thunder moon in July, of course, July has the hot and humid temperatures, and those temperatures allow for the formation of a lot of convective type thunderstorms, all that unstable air. Speaking of heat, let's talk about hot days, those hot, humid days of summer. Have you ever called them, or maybe heard somebody call them, the dog days of summer? Yeah, you probably have. Well, it has nothing to do with Fido or Rover. What it has to do with is the night sky. This particular star in the night sky. And you can find this particular star very easily at this time of the year, just drawing a diagonal line through Orion the Hunter. Keep going till you see a really bright star. It is the brightest star in the night sky. It is Sirius, known as the dog star. The word Sirius actually means scorcher. Now, it's called the dog star because it's in Canis Major, the great dog constellation. Now, people call the hot days of summer, regardless of when it is, they'll call them the dog days. But if you really want to get down there to be exactly, perfectly correct, the dog days only extend from July 3rd through August 11th. This was the time period that Sirius, the dog star, rose and set almost exactly the same time as the sun. And the ancient people, they thought, maybe, I think what's going on is that this star, Sirius, the dog star, is giving its heat along with the sun's heat, making for these hotter and hot days. Sirius, the dog star. That one last star saying to go over. This is my favorite kid-friendly one. When the stars begin to huddle, the earth will soon become a puddle. Now, I think it's based on illusion, but when you're looking at the night sky and you see all the stars spread out, they look far apart. They're doing the social distancing thing. Now, when the clouds begin to move into the area, you get the illusion, you get the feeling that the stars are starting to come in closer together, to huddle around. And this is a sign of rain as the clouds begin to increase. All right, if these are of any interest to you, there's a couple of really, really good books out there that have lots of weather wisdoms. The first one is by Eric Sloan. He was the very first TV weatherman. And the other one's by Albert Lee. And I really liked both of those. Now we're going to talk a little bit about the future. This was back in the day. Let's go back to the future. In your future, there just might be some space weather. Let's think about that. What even is space weather? Well, I am thinking that people aren't more knowledgeable or concerned about space weather because it doesn't affect their personal lives on a daily basis. Like, we don't have to wear masks because of space weather, and we don't have to be in by 10 o'clock at night because space weather is lurking around the corner ready to pounce upon us. Space weather, though, even though it doesn't affect us individually, it has a great impact on a lot of the things that we use all the time, things that we take for granted. Will always be there when we're ready to use them. So, again I ask, what is space weather? Well, here, a special breed of storms created on the sun and randomly hurled into space with unimaginable force, having potentially devastating consequences for Earthlings if the Earth happens to be in the path of the space weather. Remember, space is pretty big, the sun is pretty big, but let's talk about some of the things that space weather impacts. This rather quick overview here. Some of the main items and services that space weather could and has had impacts on. Number one, a solar storm could make transformers explode, make some of the wires melt. I mean, there's all kind of, we would be without electricity for long periods of time. And think about it. What do you use? Maybe other than a number 2 pencil. Something that you use that doesn't depend on electricity. We wouldn't have lights. We wouldn't have refrigeration. We wouldn't have the ability to charge things. We wouldn't have running water through the city pumps. Oh my gosh, we wouldn't even have internet. Haven't we become a bunch of whiners when the internet goes down for just a couple minutes? Can you imagine if all these things were taken away for a long period of time? It's happened before, it'll happen again. Radio signals. Space weather can disrupt radio signals. This is especially bad with the radio signals used by emergency responders, like back during the time of Hurricane Maria. It was very, very difficult to get relief and rescue efforts underway because coinciding with the hurricane, there was some bad space weather, and it really messed things up and slowed things down. What if we had no GPS? The GPS signals can get all scrambled during space weather impacts. Storms on the sun could really mess up the GPS system, and we've got a whole generation of people who never even learned how to read a street map, let alone fold one. And this would really, really be a sad state of affair if we lost our GPS systems. The aviation industry is very vulnerable to space weather. The space weather can impact the navigation and communication systems on board. We can lose communication with the airplanes. And this actually happened during the 1980s when President Reagan was aboard Air Force One en route to China, and there was space weather that happened that caused the plane to lose contact with the ground for a number of hours. This is very severe, and sometimes we need to divert planes because of space weather. Planes that are flying through the polar regions, which really is, I think we think of that as being one specific spot, the castle where Santa Claus lives, and that is not true. Anything above 66 degrees is considered the polar regions here. So when we have planes going through there and there's space weather and they have to divert, it can be pretty tricky. Satellites. We have had numerous satellites damaged and or destroyed by space weather. The material that is very thin that goes around the satellites, it's easily penetrated by space weather, and I think it was the year 2003 when there was some epic storms, space weather type storms, and 43 of the 70 satellite malfunctions that year were directly attributed to space weather. And of course we've got our astronauts up there. Human space exploration is really impacted by space weather. The astronauts have to be kept apprised of what's going on. So especially if they're doing EVAs, they can come inside. And this is of such great concern that the International Space Station actually has within it, built inside, something comparable. I would call it a modern day version of the storm cellar in The Wizard of Oz. You remember when they're all getting in there near the beginning of the movie? There's actually a part of the space station that has extra padding to kind of filter out some of the radiation that could be possibly wanting to penetrate the International Space Station. So hopefully what you're seeing here is that even though it doesn't affect you individually, there's lots of things out there, all these creature comforts that could be tampered with by space weather. Forgot about the money impact. Every year, globally, we have billions of money being spent to repair things that are damaged by space weather. Later on in the summer, we're going to have a program specifically on the sun. So So that this time we're not really going to go over the anatomy of the sun or the dynamics of the atmosphere of the sun. This time we're just going to go over some of the jargon that specifically relates to space weather that you need to know to better understand what's going on with space weather. Solar wind, solar flare, sunspots, and the coronal mass ejection. Let's start with this picture here. This doesn't look too bad. It kind of looks like the heat radiating off of the sidewalk at my sister's house in Florida. Well, what this is the solar wind. The solar wind is a steady stream of charged particles that flows out of the sun in all directions at hypersonic speeds. It is continuous. The Earth is generally protected from the solar wind because of our magnetosphere. But solar wind, like all wind, is invisible. I think this is really interesting. How we first came to realize the solar wind is by studying comets, the tail of a comet. Like the flag on a flagpole, the tail of a comet will show you which direction the wind is coming from. So as the comet orbits around the sun, you can see the tail going in different directions. Interesting stuff. Interesting stuff. Our next term to look at is, wonder what that could be. That looks a little more violent than the solar wind. The solar wind was just like little fingers coming up there. This looks like something evil might be taking place. This is actually called a solar flare. Unlike the solar wind that was continuous, the solar flare is sporadic. It's like a whip snap, a sudden, brief, powerful eruption of particles and intense electromagnetic radiation from the sun's surface associated with sunspots. Sunspots. I'm guessing that many of you read about sunspots when you were in school. I very definitely remember reading about sunspots in my 8th grade general science textbook, and I remember there was all these graphs and charts and really sophisticated looking things in that science textbook, and then there was a picture that looked like this, and I thought, what is that? And so under the picture there was a little caption and said that these were sunspots, and then Galileo was drawing sunspots, and there was some big deal, and I thought, can't any preschooler grab a marker and make little smudges on the sun like that? Well, turns out Galileo was right. Sunspots are a big deal. Sunspots are dark areas that appear on the surface of the sun caused by strong magnetic activity within the sun. Sunspots actually are so important. They're kind of like the baseline measure for how bad space weather is going to get. And what I mean by that is, well, first of all, sunspots, like a lot of things in nature, are cyclic. They seem to be on an 11-year cycle. At times that we have a lot of sunspots corresponds with time that we have a lot of space weather. If we don't have very many sunspots at all, then we have very little space weather. However, times we've had very low amounts of sunspots may have had a different effect on the weather. There was a time in our history, from 1645 to 1715, those years, there were hardly any sunspots recorded. Some years there were no sunspots at all recorded. That's the time period, 1645 to 1715, is known as the Little Ice Age. During that time period, there's a couple of key years, 1692 and 1693, and it's very cold. It's very cold, and I don't know. It's so cold, we got to figure out what's going on. Well, it turns out that some paleoclimatologists, which I think maybe I want to be in my next life, to study long since past weather and try to figure out how it coincides with American history or history in general. 1692, 1693 was the time period of the Salem Witch Trials. Now, one theory is that townsfolk that were kind of suffering from a severe case of cabin fever. They so tired of staying inside, prolonged winter that's been lasting for years and years and years, and they finally decide they've got to figure out not what's doing this, but who's doing this. And at that time, it was still widely believed that witches were in cahoots with the devil and could alter the weather. And so one of the reasons they went out and looked for witches was maybe because of this terribly cold weather brought on by the absence of sunspots. 2 degrees globally, the temperature dropped, which doesn't seem like a lot. In fact, if you flipped your thermometer, you could probably get it to nudge that much. But these records are pretty good about how the breakdown occurs. So if you get a 2-degree temperature drop in a global temperature, that's pretty significant. All right, let's see. Let's go to the superstorm of solar storms, and that's a coronal mass ejection. Look at this. It's this big explosion, a huge, powerful explosion on the sun's surface that spews millions, billions of tons of superheated gas into space. Now, a coronal mass ejection, and this is not an explanation that would be given to you by an astrophysicist, but this is how I picture a coronal mass ejection to be, from the standpoint of a mom and a grandma. You're feeding this beautiful, precious 6-month-old baby, and they're eating, and they're smiling, and they're cooing, and you're giving them applesauce, and you're giving them some pureed this, and you're giving them a little sip of drink, and then all of a sudden they go, blah, and it goes everywhere. It goes over your glasses, and it's in your hair, and it's on your face, and it's on the ceiling fan, and it's on the wall. It's everywhere, and it just came at you. And oh my gosh, you're wondering if it's too late to decide not to have children, and that's what a coronal mass ejection is like. It is not a good thing. It is very, very severe. So, space weather. The term space weather has been around since the 1950s. 1950s is when the term space weather first debuted, but the phenomenon of space weather has existed since time began. This is kind of hard to process. It's hard for me to believe that something that's 93 million miles away, that is taunting humanity with the possible total annihilation at some point, how that could be the very same thing that creates the most spectacular natural light show known to mankind. Something that every year people have on their bucket list. Not just sky watchers, but people from all walks of life. They want to see this light show. And what we're talking about, of course, is the aurora. The aurora is the visual manifestation of space weather. Now, people that see the aurora never forget. And nowadays you would just whip out your phone and you would take pictures, and then you would send it off to your 6,000 closest friends. Well, back in the day, ages ago, the primitive people, of course, they didn't have cameras, they didn't have recording devices, heck, they didn't even have a written language, but they had that same human need to share their joy with other people, and so they would rush to the local cave and they would make all their little drawings. They would make their little pictographs, and they would paint on caves, and this is how they would share what they saw with the rest of the world for all eternity. In fact, here's one of the most famous preserved accounts of the aurora from primitive people. Whoop, not that one. Right here. Here it is. Now, this is supposed to be, the experts have interpreted this to be a picture of the aurora. It's in a cave in the southern part of France. It's been dated back to 30,000 years ago that this is from. And it's, I don't know, I decided as I looked at this, and I'm not challenging the experts, but I've seen this artwork before. I think this, and I think I know how those little lines were made, actually. I remember my oldest son used to do this, had this artistic technique going on the top of our picnic table, and it was done by a Matchbox car. But that's beside the point. We have more than just the written records. We have other ways of knowing that the ancient people were looking at auroras caused by space weather because there is lots and lots of things in mythology. Some of the most dramatic and diverse tales in mythology have to do with the aurora. My favorite one, I've decided I listened to a bunch of them. My favorite one is from Norse mythology. The Vikings, who were undoubtedly love-starved, they're up there in the northern seas for months at a time. When they saw the aurora and they heard the aurora, they thought it was the rustling skirts of gorgeous godlike women who were dancing solely for their pleasure. That's so nice. Now, on the other hand, in China, when they saw those lights in the sky, they just knew it was the fiery breath coming out of fierce fighting dragons in the sky. In France and in Italy, they saw their aurora and they knew it was a bad, bad sign. Death was on its way, whether it was the plague or widespread war. There were all sorts of things associated with seeing the aurora in mythology. So we have these preserved accounts. Oh, I forgot about the Native Americans. Yes, the Native Americans, lots and lots of different tribes. Everybody had slightly different versions of what it was when they saw the aurora, but most agreed that it had something to do with the souls of their departed ancestors, whether the ancestors were coming to congratulate them, to warn them, to bring them news, to protect them, to give them guidance. Okay? But again, the souls of their ancestors. And then, of course, there was the Mandan Indians. I really liked that tribe. I remember that was the one that helped out Lewis and Clark and allowed them to shelter down in the winter there. The Mandan Indians would see the aurora, and they just knew that those lights were the fires under the cooking pots in which their babies were being boiled into soup. Sounds good. Soup's on. So, again, we have space weather. Space weather. Didn't hear much about it. We didn't hear much about it. Still not hearing much about it. Still not hearing much about it. I'm not sure it's even a part of our everyday conversation, even today. But what has changed? What has changed? It's not that things are different in the atmosphere, not that much different. What has changed, and we now are talking about space weather, is because we now have technology that's affected by space weather. The first technology that was affected by space weather, it's kind of hard to think of this as technology as we look back on it. The telegraph. The year is 1859. The year is 1859. All of a sudden, the telegraph system goes berserk. The press bar there, that would start quivering, and then they started buzzing, and telegraphers were getting shocked, and the metal plate was getting fused onto the bottom metal piece there, and outside sparks were starting to come off the transmission wires, and those sparks were setting off grass fires, which turned into big wildfires. And this is not even just in the United States; it's all across this country and into Europe. And one of the weird thing was that when they disconnected the telegraph from the power source, some of them continued to send messages. It was weird, and it was wild. And back then, it was fit and proper, no longer is, to say something like this was an act of God. Oh well, it happened. Nobody knew why. It was totally weird. Meanwhile, across the pond, there's a man named Richard Carrington, and he is a 33-year-old astronomer. I think this was taken a little later, unless life's been really hard on him. But Richard Carrington, a couple of days before the incident with the telegraphs, he is in his observatory, and he's kind of doing the same thing that Galileo was doing. He has his telescope pointed at the sun. The telescope is projecting an image of the sun onto an 11-inch disk in his observatory, and he's tracing the sunspots on that card. And all of a sudden, as he's tracing in the sunspots, he sees something happening. There's his card that he's tracing here, and he sees two patches of intensely bright and white light appear on the card, and he immediately thinks that there's something wrong with the filter on his solar telescope there. And so he tries to find somebody to tell, but nobody's around, and it's all disappeared. These white lights have gone in just a few minutes. About 18 hours later, in the Bahamas, in Cuba, in central Mexico, auroras are being seen. A couple days later, actually I don't know a time frame, but not too long afterwards, Richard Carrington has this sort of scientific epiphany. He puts this all together. Okay, so I saw these bright flashes on the sun, and there's these weird things happening with the telegraph system, and then there's all these auroras happening. Aha! I wonder if the three things are related. And so he publishes his theory, and it became known as the Carrington event. It actually was the beginning of the whole idea of space weather. When space weather begins to be, realized, when it begins to be realized, and the Carrington event became the cornerstone of space weather. And again, looking back at past weather records, they now believe that the Carrington event was on account of a 500-year storm, a 500-year event, a coronal mass ejection that happened on the Earth. Remember, though, that outside the scientific world, this is kind of totally swept under the rug. People forget about it until over a century later, 130 years later, 1989, something similar happens. It's a blackout, and millions are blacked out. The entire province of Canada, Quebec, is blacked out. It's called the day the sun brought darkness. Astronomers witnessed a powerful explosion on the sun. Within minutes, tangled magnetic forces on the sun had released a billion-ton cloud of gas. It was like the energy of thousands of nuclear bombs exploding at the same time. The storm cloud rushed out from the sun straight towards Earth at 1,000,000 miles an hour. The solar flare that accompanied the outburst immediately caused short-wave radio interference, including jamming of radio signals from Radio Free Europe into Russia. Now, read this part with me. It was thought that the signals had been jammed by the Kremlin, but it was only the sun acting up. Can you imagine the disaster that could have happened if the scientists hadn't stepped in and said, this has been caused by this big blackout that caused the collapse of the hydroelectric system up in Quebec. That was caused by a solar storm. If we had reacted immediately and done something drastic like bomb Russia, that would have been unbelievable consequences. And similarly, back during the Vietnam War, the year's 1972, and a whole bunch of sea mines all of a sudden are detonated. And here's the account. On August 4th, 1972, dozens of mines hiding in the waters exploded in little more than an instant. And American troops had laced the seas bordering North Vietnam with thousands of mines lying in wait for ships to pass by. But in this case, no ships had set them off. Not until the 1990s, when enough time had passed that they declassified all this information, were those experts able to go back and figure out what had happened. And this corresponds perfectly with a huge solar event that, doing this again. It was another coronal mass ejection that had taken place that had caused these magnetic sea mines to detonate. A solar storm triggered a Vietnam War mystery. So after the 1989 events, things start rolling. A lot of different nations begin to decide it's time to get prepared for the unexpected. And we're getting pretty good at being prepared for the unexpected by now. And in the year 2007, we have the Space Weather Prediction Center actually is formulated. It's part of the by space weather. It's not just for the average me and you to call in and listen to, like when we used to dial on our rotary phones, WE11212, and you could listen to somebody that sounded like your grandma giving you a forecast. This is a much different sounding forecast.
Because we are still climbing out of solar minimum, the cosmic reflux is a bit more intense than we'd like it to be, so you frequent flyers, and this does include aircrew who fly over 800 hours annually and fly at high latitudes and high altitudes. You are in the marginal range for radiation dose, and this does include prenatal passengers, so please take this into consideration in your flight plans.
Thank you. And if you're interested in this, if you feel the need to know more about space weather, there's several good websites that you can go to, and of course there's a whole variety of different apps you can get for your phone that can give you space weather alerts whenever you want them. And I don't know, maybe this is just the thing you've been looking for to get out of your next kind of boring staff meeting. This one in particular, I really liked the sound of this. You can tell all your people in your meeting, all your coworkers got, that alarm is telling me that there's errant activity on the sun in Gamma Quadrant Sector 4. Gotta leave. Seriously though, get involved with becoming a storm watcher. Citizen science is the same people that have us counting backyards, the people who help us band butterflies. Citizen science has a whole variety of astronomy activities that you can participate. There are 16,000 people globally that have become solar storm watchers, and they're actually trained to interpret through some tutorial, information that is coming back from the stereo satellites that are orbiting the sun. Yeah, it kind of sounds like an interesting thing to do. You can serve your country, advance science, and maybe it'll keep you from going stir crazy during the pandemic that is not seem to be ending soon. Now we're going to go to our next section. This is kind of my special request section. Every week I hear this voice. Every Sunday morning when I listen to KHR, WKHR, and here's our voice.
Let me see what spring is like on Jupiter and Mars.
You know who that is, right? That's Frank Sinatra, famous Frank Wonders.
Jupiter and Mars.
He's wondering about weather on other planets. And I figure if he wonders, that maybe there's other people out there that wonders whether or not there's weather or not on the other planets. So let's go through them rather quickly. Let's first take a look at Mercury. Closest planet to the sun, you go to Mercury, the sun's going to appear 3 times bigger, 10 times brighter, and it gets hot, of course. How hot does it get? About 801 degrees is a high temperature, and a low temperature of a minus 279 degrees. That's a huge temperature spread. In fact, this is the largest diurnal day-nighttime temperature spread in the entire solar system. Can you imagine trying to pack your suitcase to include a wardrobe that would cover 1,000-degree temperature spread? But you don't really have to worry about that because we're not going anytime soon. The focus is on Mars, and besides, Mercury gets really bad Yelp ratings because it lacks atmosphere. So let's go to Venus. You want to go to Venus? I don't think so. Venus even looks like the sun. It is so hot. The forecast for Venus, concise, consistent. The forecast for Venus is hotter than Hades and 100% chance of nastiness. You're on Venus, your daytime high temperature, 900 degrees. Now, whereas Mercury had 1,000-degree temperature spread, look at our temperature spread here. Our low temperature, a bone-chilling 820 degrees. So there's only an 80-degree temperature spread here. The atmosphere of Venus is so thick and so toxic that the heat that comes in never really goes away. It's just there. It's the greenhouse effect. It just keeps getting hotter and hotter and hotter. It also has a pressure that is 92 times higher than here on Earth. And that's sometimes, besides it being compared to a greenhouse, and you've heard of the greenhouse effect on Venus, the runaway greenhouse effect on Venus, with that heat that isn't allowed to escape. But also on Venus, we have, with that high pressure and the heat, it's sometimes referred to as the pressure cooker environment. And I've been thinking about getting a pressure cooker, and I'm not even going to check Consumer Reports, because as soon as I saw there was a pressure cooker called the Venus pressure cooker, I said, that's the one I'm going to get. That sounds cool. And you don't even have to wait for, well, you can't really wait for a refreshing afternoon shower, because when it rains on Venus, the rain never gets as far as B.J. Thomas talking about the raindrops falling on your head, but it's not rain like we know it. It's acid rain. Ew. Let's leave. Let's pass Earth and go straight on to Mars. The way I figure it, everybody probably has a couple pieces of information about Martian weather somewhere in their mind. Neither thing was taught to them by a college professor, but that's okay. The first bit of information that you have probably came to you via the blockbuster movie The Martian. From watching The Martian, we learn that if you go to Mars, you're probably going to encounter a dust storm or two. And that's true. They have dust storms annually. Dust storms that last a couple days to a couple weeks. And then every 5.5 years, they have dust storms that are global dust storms, like the one that took the life finally of opportunity. Global dust storms that last from months, maybe even on into a year. So, yeah, there are dust storms on Mars. Now, watching The Martians, though, gotta mention this, it's very important. They keep hassling Andy Weir about this. He wrote The Martian, and it was science fiction. He meant it to be science fiction. He did not mean it to be an educational video. And he keeps getting hassled about the beginning of the movie. Even NASA has an official statement about that. The wind and the largest dust storms on Mars likely could not tip or rip apart major mechanical equipment. The wind's strongest Martian storms top out at about 60 miles per hour, less than half the speed of some hurricane-force winds on the Earth. Again, he didn't mean it to be an educational video, so the winds on Mars aren't strong, but that's because there's not much atmosphere on Mars. Less than 1% of what we have on Earth. The other piece of information I think, at least I have in my head, the other piece of information about Mars that we have comes from this. You know who that is? Mars is as cold as hell. Yes, Peter, that is kind of an oxymoron. You don't think of hell as being cold, but in this case, as cold as hell means extreme cold. The average temperature on Earth globally is 57 degrees. The average temperature on Mars is a minus 81 degrees, and that is as cold as hell. At any moment, any one of you can type in Martian weather report on your computer, and you will get a nice current weather on Mars. You can even call up like you used to call W11212, and you can get a Martian weather report.
A lot of the dust storms we've been seeing, especially those back in November, are beginning to die down. Now, back in November, you can see we have...
Why would you even want a Martian weather report? Well, here's a good reason why. My husband cut this out for me back in October of 2020, and I really liked it. And it does say a lot in this article. One of the it talks about how Mars 2020 mission was probably much more popular than it would have been in a non-pandemic year. The reason being, people needed a distraction. They needed something positive in their life besides a COVID test. So they were following the Mars mission. And what this interests me most about in this article is that it goes on to tell you that in 1914, right at the onset of World War I, Henry Pickering was hired by the New York Herald to write Martian weather reports to be published in that newspaper solely to serve as a distraction from the atrocities of war. So this was something that people could read and think about and wonder about. And at that time, 1914 is a good 60 years before, stuff starts really happening on Mars with the space program. But so all of them were 100% fabricated, and he always made Mars seem like some dream world. Over the last 40 years, we've sent, so we went from being super stressed. After you think about Mars and call up and get your Martian weather report, you will feel all warm and fuzzy inside. Now, for the last 40 years, we have sent numerous orbiters and landers and rovers to the planet Mars. So we do have a pretty good handle on the current weather, the present weather on Mars, but what we don't know about is past weather. We've received thousands of images from Mars, many of which look like this Pale Crater, this Jezero Crater, and these clearly look like landscape features that had to be formed by vast amount of water, vast amount of standing water, running water, falling water. But where did it all go? If all of that water hadn't disappeared, Mars would look a lot like a planet that you know. It'd look, instead of like it does now, it'd look like that. You recognize that planet? That'd be the planet Mars looking a lot like Earth if there was water there. We do have a satellite up there. It's been up there for quite a while now, since 2014. We have MAVEN, the Mars Atmosphere and Bioevolution spacecraft, and its primary mission is to try to figure out where the Martian atmosphere went. And we don't hear much about MAVEN because it has no onboard camera, but it has lots of weather instruments, and using those instruments, it's detecting the solar wind and charting the number of different storms that are happening on Mars, and it actually witnessed firsthand a very direct, strong attack of space weather on Mars back in 2015. Again, there's no camera, so all this data that it received was given to an artist that was challenged with making a rendition of what it must have looked like, and this is what they came up with. So you can see the particles coming off the sun. It looks like a massive coronal mass ejection, and you can see what's happening here is the charged particles from the sun are interacting with the gases from the very frail upper atmosphere of Mars there, and it's blasting those particles out in space. It's further stripping the atmosphere away from Mars. Poor Mars. Oh, we don't want to forget Frank, and he wants to see what springtime looks like on Jupiter and Mars. Well, here's Mars, Frank. You can just begin to see the sand dunes emerging from the winter crust of carbon dioxide ice there in the northern Mars. Can't show you springtime on Jupiter because there's no springtime on Jupiter. In fact, there's no seasons whatsoever, Frank. But what they do have is the most iconic weather feature in the whole solar system. And we're going to talk about that in just a minute. But, I kind of steer away from red dots like that. What really attracts me to Jupiter are these stripes. I think get back there. Are these stripes? Okay, so we got these stripes here. What these actually are, they're alternating layers of clouds, and the clouds are different colors because they're at different levels. They're going different directions, and they're going at different speeds. I think that's really awesome. And yes, the Great Red Spot is awesome. It's great. It's size-wise, meaning great. It's actually shrinking. It used to be 3 times bigger than it is now. We don't know why. And what I learned by doing a lot of this research is we don't say we don't know why anymore. We have to say it's a subject of active research. So, the subject of active of research why it's getting smaller. But what I find most extraordinary about the Great Red Spot is how high it is. Most of our tropical cyclones extend no farther than 10 miles up into our atmosphere. Look at this. The Great Red Spot goes up 200 miles. And the winds of the Great Red Spot are 400 miles plus per hour, much, much stronger than our storms here on Earth. By the Saffir-Simpson scale, we figure this to be about a Cat 14. And my husband did all those calculations of 400 mile an hour wind. That's one of my favorite charts. I think that's a neat chart. So, yes, I ran across this. I thought this was very interesting. We don't know if we're still looking at the same red spot that was first observed in 1664. We don't know if it's the same one that we see today because there was a lapse in the record keeping. However, there is this really awesome picture. This was done in 1771. It's part of a set. Here's the other two in the set. This is a technique called forced perspective. You're automatically drawn to the biggest thing in the picture. Biggest thing in that middle picture is Jupiter. These were done, and they hang now in the Vatican. They were made for Pope Clement XI. And the interesting thing isn't the fact that that's Jupiter. The most interesting thing about this picture is the fact that it's the very first time the redness of Jupiter is actually brought out. It's more than 100 years later before scientists started describing it as a great red spot. But here, Donato Criti, he has it up there. And so we know at least the great spot that we're looking at now has been around at least 150 years. Oh, there's that red spot. Okay, let's go to Saturn. I think we're so caught up with the wonderfulness of the rings of Saturn, how gorgeous they are, how spectacular they are. We don't tend to notice anything else about that planet. But sitting right there at the northern hemisphere is a hexagon. And that hexagon, first detected in 1989 when Voyager 2 flew by, and confirmed again in 2008 during one of the Cassini missions. This hexagon is a big storm, and the vortex is actually as big as the United States, and up it's a subject of active research. They're not really sure how it gets this hexagonal shape, but what they think has happened is the big vortex at the North Pole has spawned 6 little minor storms that have drifted south, and they've kind of found positions because they're repelling each other, so they're equidistant apart, and they're shooting these jet streams from one storm to another. That's what's hot. Again, a subject of active research. Let's keep going. Let's go to Uranus. I listened to so many accounts about weather on Uranus, and they were just kind of disgusting. And again, the only thing that it reminded me of was the Grinch. Remember, there were 3 words that best describe the Grinch, and they were, remember, stink, stank, and stunk. The atmosphere of Uranus has multiple cloud depths. The one nearest to the surface has a lot of ammonium sulfide, which is the key ingredient that gives stink bombs their stink. Next up is ammonia, which is found in a lot of fertilizers. And then the last layer is hydrogen sulfide, which is the classic rotten egg smell. So Uranus's weather, just kind of smelly. And now we go to Neptune. Now Neptune, everything about Neptune, first of all, Neptune is 2.5 billion miles away from the sun. The fact that it has weather at all is pretty extraordinary, I think. But Neptune, even though it's much further away from the sun, is warmer than Uranus. It has the highest winds in the entire solar system, supersonic winds, and it also has a big spot. It doesn't get near the publicity as the Great Red Spot, probably because it's so far away and we've only gone by it once, but the Great Dark Spot has recently gotten a little bit more publicity because the Hubble telescope took a picture of it, and it spawned a couple of other storms further south of it, and it also took a U-turn. Why? subject of active research. Nobody knows. Nobody knows why that is. All right. Our last segment, it's more of a tribute than it is a discussion on weather satellites. Weather satellites. The very first weather satellite. I think I need to go back even a little bit before that. I can think of nothing that would more instantaneously or drastically improve the forecasting capabilities, especially long-range forecasting capabilities, than placing an eye in the sky. And it's kind of hard to imagine that 11 years before Sputnik is even launched, they began talking about putting a camera in orbit. Putting a camera in orbit to cover some of these areas that heretofore had no coverage whatsoever. No human observers, no buoys out in the oceans. So the plans to have satellite are underway. Through the Vanguard program, the Explorer program, both had some satellites, some weather instruments launched into space, but none of them performed properly. And so the first weather satellite honors go to TIROS-1. Now, look at this image that comes in, this picture that comes in. If you got that on your phone today or saw that on your own TV, you would immediately take your device to a store and buy a replacement. This is terrible, but it was beginning. It was the beginning, baby step. Let's go back to the last one. Look at today's satellite image from space. Look at the eye wall of that hurricane. Look at these bands of clouds, and you can see the high level, the high builded up cumulonimbus clouds. It's spectacular. But when you look at Tyros, these were so grainy. And what I remember most, they came in on this machine called a fax machine that it smelled so bad. It just smelled like the whole place was on fire, kind of like when you plug in a glue gun and 2 minutes later everybody's sniffing around saying, I think something is caught on fire in here. And the fax machine was really quite the instrument. You had to take the maps, you tore them off of this big machine, and then you had to wait for them to dry for a few minutes, and you could tape them all together. And back in Alameda, California, at the weather station, we even had an old turntable that they would kind of put those pieces of the pictures on, and then you could see the movement of the storm. It was very basic, but again, it was the beginning. This was so spectacular. This was leading edge, space age tool, and here is, it was so popular globally that they actually, many countries issued postage stamps with the pictures of Tyros on them. It's really cool. Almost immediately was it realized how valuable this could be. It also was realized almost immediately that we needed additional satellite coverage. This could be the most interesting thing I found in my entire presentation. I did not know this. Of course I knew about JFK's moonshots speech to the Congress. I think especially after the 50 years of Apollo, we all know that he said, we choose to go to the moon before the end of this decade. Well, in that first speech that he makes to Congress asking for money for the Apollo program to get man to the moon, in that very same speech, just a minute or so later, President Kennedy also says he's requesting an additional $75 million, of which $53 million is for the Weather Bureau, which will help give us, at the earliest possible time, a satellite system for worldwide weather observations. I think this is fantastic, that this coincides with the landing on the moon. And by the way, that $75 million back in 1961 equates to about $638 million in today's money. So, that network of weather satellites has been in place now for several decades. this isn't a study all night, but there's 8 countries that actually have weather satellites up there. We've got about 20 up there at any given time. The satellites have evolved from the Tyros program. Next came Nimbus. Now we're in the GOES satellite system family. They orbit about 22,000 miles up. That's compared to the International Space Station, which is only about 250 miles up. We're talking 22,000 miles out. There's no place that's left without coverage, satellite coverage for the weather program. Way out here in the upper right-hand corner, there's another satellite that is almost 1 million miles away. It's a Lagrange point 1. It's orbiting the sun. It is our prime satellite that is giving us real-time information about incoming solar wind. And it can give us as much as 15 minutes to an hour's warning when we've got active space weather coming. That is a satellite that my husband and I actually were at Kennedy Space Center when that satellite was being launched. We were all ready. This is the big banner that's by the fence right next to the reviewing stand. So we're sitting down here, the lower part of your screen, and it's kind of hard to see where the rocket is across the Banana River there. We're sitting there. Well, it's hard to see the rocket, but what isn't hard to see at all, you see these low clouds, these threatening clouds? Well, because of the weather, it was postponed. We thought it was canceled, and I was devastated. But the good news is that it did launch the next day, and we were ever so happy. It was just great. And I would wish that every one of you could have such a thrill. It was really, really thrilling to see it go off. So, I am going to end my talk here like I've ended every weather talk I've ever given by this little weather jingle that I remember from years ago. As a rule, man's a fool. When it's hot, he wants it cool. When it's cool, he wants it hot. Always wanting what is not. Remember, the sun shines in you, not on you. Thank you for listening. I'm going to stop screen sharing, and if there's any comments or questions, I'll try to answer those for you.
Thank you.
Thank you. Thank you. Any questions? Did you see that dedication, Dan Mealy? You did? Okay, good. There's my boss from the weather office.
Great job, Jen.
Thank you. Thank you. Any questions?
First one for me.
Maybe you said this at the beginning. I missed the first couple minutes. How did you get so, well, you mentioned about being in Alameda, but how did you really get so interested in the subject and know so much about the space weather?
Just through lifelong learning. The things that I find it really hard to learn things that I'm not interested in. I mean, they just kind of go right off my head. But if I'm interested in something, I just can't get enough of it. So I just, I read a lot of books. I listen to a lot of podcasts. I watch a lot of DVDs. Just anything I can get on the topic. It's really kind of hard to get books on space weather because it's an emerging science and it's also a subject of active research. So everything is always changing. But if I like something, I just keep learning about it, and I like that. I like to do that. So anybody else have any questions to say? Nobody brought me anything to eat. I'm really hungry. I hope someday I get to do a live performance because I think I really like, I know I really like the interaction, the seeing people. Like I can only see 3 people right now. I guess if I went to participants, I could see some names of people. But thank you so much for coming. This is great.
Dan, when's your next episode? You are a very good teacher. And I'm an old person, and I learned a lot.
You're an old person.
Yeah, I mean, gee whiz. It was very well done. Thank you.
Thank you. Thank you very much. there's one of these every month. There's a different speaker every month. I'm up again in July, so
Good.
I'll be doing one specifically on the sun, and it'll include things from the sun, about the sun, from facts, and my friend's going to help me find some sunny songs beside "Here Comes the Sun," and there'll be a lot about the atmosphere of the sun and the dynamics of the sun, and probably even more space weather stuff.
Yep. And our next program will be April 5th. That's going to be a woman from the International Women's Air and Space Museum. So keep an eye on our website for that one.
Jan, are they being recorded so that they can be put on as podcasts or something?
At the moment, we're still kind of toying around with that, figure out how we can record these things and get them up for people. So this one may not be, but I hope that our future presentations will.
Well, I actually am taping tonight. And so
I wish I had.
I will
It was
be
recorded.
on our,
Oh,
it'll be on our YouTube channel.
Oh, it's this Heidi. Okay.
Good, Heidi. Thank
Yes.
you.
oh, terrific. Okay.
And there's no people's faces on it, it's just Jan.
Oh, excellent. Yeah.
Good.
Oh, that was excellent, Jan, thank you.
Yes. I love your visuals, Jan. They just make it come alive. This is awesome.
Oh, thank you. Thank you.
I like your Yelp review, Joe.
Well, I figured that everybody looks at Yelp, so, you gotta.
I can hardly wait for your next class. It was very
Thank you.
knowledgeable and enjoyable. Thank you.
Thank you very much.
Any other questions for Jan this evening?
Nice learning about the solar cycle, because it does affect ham radio.
Yes, it does. Very much so. Are you a ham radio operator?
Yes, I am.
Yeah, that's my husband behind me. I don't know where he's somewhere back there.
When was the last time you think you had space weather interference?
We're at the low point of the solar cycle now. It's starting to go back up again.
Yeah.
So the communication's getting better.
Now, is there a spot that amateur radio, do you go to the Space Weather National Prediction Center to get your information, or?
Well, we'll see if the club might like to listen to something like this.
Well, really, the state of Ohio sends an email out. There's a guy that does all the solar studies, and he sends an email out warning us that there might be a solar flare or sunspots or something. So we do get something monthly, if not weekly, if there's an incident.
Okay, great.
Okay. I want to thank you all for joining us this evening.
Bye.
Have a wonderful night, and we'll see you all next month.